Hello friends, I am from Chemistry faculty of QLS Academy. Today we are going to learn about strength of acids and bases. Why acids like sulfuric acid are dangerous to touch, while citric acid in oranges is okay for consumption. I hope you will enjoy today's learning. So let's start with our today's lesson. You have come across many types of acids and bases. Some of them are consumable while some are dangerous even to touch. Have you ever wondered why? It is because of their strengths. Some acids are considered as strong acids, while some are considered as weak acids. Similar is the case of bases. Now, what gives acid and bases their strength? How can their strength be determined? हम ये कैसे कह सकते हैं कि कोई acid strong है या कोई base weak है? Now, do you remember that acids can produce H plus ions, hydrogen ions in solutions? So, acids when dissolved in water produces hydrogen ions. But hydrogen ions cannot exist freely, so they combine with the molecules of water to form hydronium ion, H3O+. For example, when hydrochloric acid, HCl, is mixed in water, it releases H plus ion and Cl minus, means chloride ion. Since hydrogen ion cannot survive freely, it combines with H2O, water, and forms hydronium ion. So, HCl produces a hydronium ion and a chloride ion. Now, do you remember that there are bases which can release OH negative ions, means hydroxide ions, when mixed in water, and there are also some bases which are not able to release hydroxide ions. For now, we will take only the hydroxide ion releasing bases into consideration. Such bases are soluble in water and are specifically termed as alkali. जो bases water में soluble होते हैं, हम उन्हें alkali कहते हैं. So, when an alkali is dissolved in water, it releases hydroxide ions. For example, when sodium hydroxide is dissolved in water, it dissociates into sodium cation and hydroxide anion. The hydrogen ion and hydroxide ions released by acids and bases are responsible for carrying out neutralization reaction, which we have already discussed in last class. Apart from being responsible for all the chemical properties of acids and bases, these ions are also responsible for conduction of electricity by them. Now, a very important fact. While making an aqueous solution of an acid or a base, it is mandatory to add the acid or base in water, not water on them. Acids and bases का solution बनाते time हम acid and base को water में add करेंगे, acid और base को water में add करेंगे, ना कि water को acid and base में. It is because the process of dissolving an acid or a base in water is highly exothermic reaction. A huge amount of heat is produced during the process. इतना ज़्यादा heat produce होता है कि हमारा beaker या test tube break भी हो सकता है. So, addition of acids and bases in water should be slow with constant stirring, so no localized heating could occur. This mixing of acids and bases in water results in the decrease of the concentration of ions produced by them. Imagine it like a situation where you have 10 chocolates all by yourself. Then a friend of yours comes in and you share the chocolates with him. Now each of you get 5 chocolates. Here the number of chocolates per head decreased with the number of consumers. When more of your friends come in and you share the chocolates with them too. Say now there is a group of 10 friends. Now each of you will get 1 chocolate. So here the number of chocolate per head again decreased from 5 to 1. पहले आप अकेले थे, आपके पास 10 चॉकलेट्स थी, फिर आपका एक फ्रेंड आया, आपने उन 10 चॉकलेट्स को उसके साथ शेयर किया, यू गेट 5 and 5. बट देन आपके और फ्रेंड्स आए, तो आपने उनको और फ्रेंड्स के साथ शेयर किया, देन ईच ऑफ यू गॉट 1 चॉकलेट. सेम ऐसा ही होता है जब हम एसिड्स एंड बेसिस को वाटर में ऐड करते हैं. Before addition of water, the respective ions of acids and bases were retained by themselves only. But as water was added, the ions got distributed among the particles of water. Hydrogen ions got picked up by the water particles to form hydronium ions, while hydroxide ions remain suspended until it reacts with a positively charged ion. So, this phenomena of decrease in the concentration of ions per unit volume is known as dilution. जब किसी एसिड या बेस में हम वाटर ऐड करते हैं तो ये डाइल्यूट हो जाता है. इट इज सेड टू बी डाइल्यूटेड. नाउ बैक टू द क्वेश्चन, हाउ कैन वी से दैट सम एसिड्स आर स्ट्रॉन्ग व्हाइल सम आर वीक? हम एसिड्स एंड बेसिस की स्ट्रेंथ कैसे मेजर कर सकते हैं? We can determine the strength of acids and bases by finding the amount of H plus and OH negative ions given out by them in solution. A strong acid dissociates completely to give out hydrogen ions, means all the molecules of acid break down into H plus ions and the anionic component. For example, hydrochloric acid HCl dissociates into H plus and Cl negative ions. While weak acids are not able to completely dissociate into ions, they partially dissociate to give out H plus ions and the anionic component. Here you can see that acetic acid can dissociate into H plus ion and CH3CO negative, means acetate anion. And you can see the arrow. This arrow goes in both the direction. Arrow दोनों direction में जाता है, means acetic acid CH3COOH एक बार break होगा, then H plus और acetate आयन दोबारा कंबाइन होकर फिर से एसिटिक एसिड का मॉलिक्यूल फॉर्म करेंगे. दिस इज नोन एज पार्शियल डिसोसिएशन. Similar is the case of bases. Strong bases dissociate completely to form hydroxide ions and its cationic counterpart. For example, sodium hydroxide NaOH dissociates into sodium cation and hydroxide ion, while a weak base partially dissociate to form hydroxide ion and the cation. For example, ammonium hydroxide dissociates into ammonia cation and hydroxide ion. Notice that two-sided arrow is still here. The strength of acids and bases are measured using universal indicator. Universal indicator is a mixture of several kind of indicators. It gives out different color for different concentration of H plus ions in a solution. So, the scale which measures the concentration of H plus ions in solution is named as pH scale. pH stands for power of hydrogen or potential of hydrogen, means किसी solution में कितने H plus ions present है ये detect करता है हमारा universal indicator. The higher the concentration of H plus ion, the lower will be the pH. जितना ज़्यादा concentration होगा H plus ion का, pH उतना ही कम होगा. pH scale ranges from 0 to 14. Acids have a pH lower than 7, while bases have a pH greater than 7. pH 7 means neutral solution, a solution which is neither acidic nor basic. At pH 0, the concentration of H plus ion is highest, while at pH 14, the concentration of OH negative ion, means hydroxide ion, is the highest. To check pH, the pH strips are used. These strips are soaked in universal indicator and are readily used. Most of the strong acids have pH lower than 3, while weak acids have pH greater than 3 but lower than 7. While strong bases have pH greater than 11, while weak bases have pH greater than 7 up to pH 10. pH 7 is the midpoint of the pH scale. It denotes the neutrality of a solution where the number of H plus ion and the number of OH negative ions are the same. The substances which are neither acidic nor basic lies in this area. For example, pure water. Here is the list of pH of some day-to-day useful substances. You can see that the cleaning agents we use have a pH greater than 7, while there are many food items which have a pH lower than 7, like the citrus fruits, tea, coffee, tomato, all have a acidic pH. Now, let's see the influence of pH in our daily life. pH plays a very important role in our survival. Can you drink acidic water? What will happen if the pH of your blood becomes too acidic or too basic? What will happen if the pH of the soil becomes acidic? Will the plants and other organisms would be able to survive in such a soil? Would you be able to survive by drinking acidic water? Everything have a definite pH to support life and other activities. The pH of our blood is around 7.4. A slight decrease or increase in this pH can be fatal for our survival, as working pH range of our body lies from 7 to 7.8. The pH of rainwater is usually 5.6, but when the air pollutants get dissolved in rainwater, its pH further decreases, which leads to acid rain. This acidic water, when flows down the water bodies, disturbs the life of aquatic organisms. Acid rain not only lay havoc to aquatic life forms, but it also causes mass destruction of the object it comes in contact. pH is also important for the growth of plants. Each variety of plant have a specific range of pH in which it shows healthy growth. Usually, plants grow in the pH range of 5 to 7. Plants अच्छे से grow करते हैं pH 5 to pH 7 के बीच में. For example, wheat, cotton, barley, corn all grow best at pH range 5.5 to 6.5. Our body also produces acid to digest food. Our stomach secretes hydrochloric acid, which helps in digestion of food. The pH of this acid is around 1, but surprisingly, it do not cause any harm to our body until it is produced in a sufficient amount. Too much production of acid leads to acidity. To cure acidity, we use antacids, which are nothing but bases. The basis of antacid neutralizes the acid and thus releases us from acidity. हमारे स्टमक में हाइड्रोक्लोरिक एसिड प्रोड्यूस हो रहा है, मतलब ये नहीं है कि हम एसिड को कंज्यूम कर सकते हैं. This acid can't cause harm to our stomach because of lining of special cells inside our stomach. There are many animals and plants which secretes acid as their defense mechanism. कुछ plants और animals भी होते हैं जो acid को as a defense mechanism use करते हैं. Like ants and bees, when attacked, secrete methanoic acid through their sting directly onto the attacker. Plants like stinging nettle also secrete methanoic acid to avoid itself from preying. The sting of bees, ants and nettle leaves can be cured by applying bases like baking soda on the sting site. Bases neutralize the acid injected and relieves us. Now, what will happen if there is some variation from the standard pH? जो एक standard pH होना चाहिए, जब उससे थोड़ा भी variation आता है, pH ज़्यादा या कम हो जाता है, तब क्या होगा? The usual pH of our buccal cavity is around 7. It is the pH before having a meal. खाना खाने से पहले हमारे mouth के अंदर pH around 7 रहता है. But after having a meal, it drops to 5.8. pH 5.8 is also not harmful to our teeth. Our teeth are made up of calcium phosphate and it is the hardest substance in our body. The problem begins when this pH further drops. Problem तब start होती है जब pH further drop होके 5.8 के भी नीचे आने लगता है. The food particles stuck between the teeth are digested by natural bacteria present in our mouth. जब bacteria in food particles को digest करते हैं, they produces acid. This acid, if left there for a long time, starts eroding the enamel of our teeth and this causes tooth decay. That's why it is advised to wash mouth after you eat something. Notice that हम teeth clean करने के लिए जो toothpaste use करते हैं, वो toothpaste भी basic होता है. It is basic in nature. The acids produced in our mouth is neutralized by the basic toothpaste. So friends, this was all for today's class. Today we learned about a very important concept, the concept of pH. You will need to remember this for all your life, as application of pH is not just limited to science lab. It has a wide application in our daily life too. Hope you all have enjoyed today's learning, and if you have any doubt or need any further information, you can visit the following link.